Yes, for question 2, WAEC 2025 practical, physics practical to be precise. I am predicting that the question that will be repeating for this year's question 2 is the year 2010. So if you have your past question, check out WAEC 2010, June 2010. Okay, question 2. Okay, I am predicting that that's the question that will be repeating. Okay, now look at it. I have the diagram on the board and I'll be reading the instruction. Okay, as I have it here on the past question. Okay, so you just follow me as I guide you on how to perform this experiment. Okay, it's all about refraction, it's optics. Okay, so like we have on the diagram, look at the diagram. What you have here is the plane mirror. This is the plane mirror, this line. The plane mirror is attached to the rectangular prism. Okay, and this is the experiment you are expected to perform. Okay, and this is the rectangular block. Assume that the board is the plane sheet. Okay, assume that the board is the plane sheet, the white board is the plane sheet. Now let me read the instruction. I love physics practical because it always comes with instruction, and if you follow the instruction, you find yourself doing the right thing. Okay, now let's go by the instruction. Okay, you are provided with a glass block, plane mirror, and optical pins. Instruction number 1: place the glass block on a drawing sheet. You'll be given a plane sheet. Okay, so the first instruction says you should place the glass block on the plane sheet. Okay, so on a drawing sheet and trace its outline ABCD. So once you have put the rectangular block, let's assume this is my rectangular block, you place it here, you outline it, use your pencil to draw it out on the plane sheet, and that is what we have here. Okay, AB, then you label it ABCD. ABCD, yeah, ABCD, you label it. Then instruction number 2 says remove the block, measure and record the width W of the block. So if this is my block, you are expected to measure from this point, that's the smaller side of the rectangular block, you are expected to measure this side, this place, as the width. As you can see on the board, AD or BC, this is the width. You measure and then you record. Please don't throw it away. You record it as W is equal to, and of course in 2 decimal places. Okay, so the next instruction says draw a normal ON to DC. Okay, before this, looking at the diagram, you draw a straight line, midline. Okay, you have outlined it. You are free to measure this AB. Then you find the midpoint and then draw this line in the middle and then put your right angle. Okay, before this instruction, so draw a normal ON to DC. So we are going ON to DC at a point about 1/4 the length DC. So this is DC. Okay, this is half, where you have the original normal, the first normal. Okay, now this is the normal, and they say we should draw another one which is 1/4 of DC. So if this is half of DC, the quarter will be half of the half. Okay, half of half is 1/4, and this is it. This is the line we have drawn, and that's the next instruction. So let's go for the next. You draw this line. Okay, so after you have drawn that line, draw a line making an angle I is equal to 10 degrees. So on this normal that you have drawn 1/4 of DC, you are going to put your protractor here, this place. Okay, you put your protractor here. Ensure that you from this normal, okay, from this normal here, you measure 10 degrees. Okay, if you have your protractor, I think it will be somewhere here, then you put a dot showing that that's your 10 degrees. Okay, after you have done that, then that dot you have drawn, trace it and connect it with this point here. You draw a line connecting it to this point that you have here. Okay, now let's check out the next instruction. Draw a line making an angle I. So we have our I to be 10 degrees with the normal. Replace the block on its outline and mount the plane mirror vertically behind the block such that it makes good contact with the face AB. So after you have drawn this, you are expected to put the rectangular block back, okay, to the outline. Remember, you drew an outline of the rectangular block, so you put it on the outline. Make sure it is aligning, okay. Make sure you maintain the outline you drew, okay. So once you have done that, you put the plane mirror here. You put the plane mirror at the back here. So once you put the plane mirror, you stick two pins P1 and P2 on the line MO. Where is MO? This is MO. You put two pins on this line. You put pin 1 here. Make sure it is spaced. Then you put P2 at the other point. Okay? So now we have this. The next instruction says, looking through the face CD. This is CD, right? Okay? Stick two other pins P3 and P4 such that they appear to be in a straight line with the images of P1 and P2 seen through the block. So you come here, okay. This is where you are going to be doing the experiment now. You'll be given 4 optical pins, okay. You'll be given 4 optical pins. So you have put 2 here as P1 and P2, okay. Now the other pins is what you are going to be using to perform the experiment after you have put the rectangular block with the mirror on the other end, okay. Now you look through this side and try to align this P3, P4 with what you are seeing in the rectangular block, okay. You are aligning just like when you are on assembling and they say be on a queue, on a straight line. So you want to put P3 and P4, okay, on a straight line with P1 and P2, okay. So once you have put P3 and P4 on a straight line with P1 and P2, if you are sure that this is now at the back of P3, then the next one, P4, is at the back of P3, you put your pins, okay, one after the other. You don't do it at the same time. You do it one after the other. Once you have achieved that, okay, with a straight line and extend it to touch the face CD at O prime. So look at O prime here. So after you have achieved this, you are sure that P3 is on a straight line with P2 and P1. P4 is on a straight line with P3, P2, P1. You can now draw a straight line joining this face CD. These 2 pins, these 2 dots will be the guide, okay. So it means you are going to be using your ruler to align with these 2 points to touch CD, okay. Once you have touched CD, you can now draw a normal on this line that you have gotten from P3 to P4. Then you join this point and this point together, join this point and this point together, and then you measure theta with your protractor, of course, okay. With the help of a protractor, you measure theta, okay. Now draw a perpendicular line from the midpoint OO prime to meet AB at Q, okay. Look at the perpendicular line to meet AB at, though I have done that in the beginning, okay. So if you do not do it at the beginning, you can still do it now. Draw line OQ. Let's take it one step at a time. Draw line OQ. Where's my Q from the diagram? Okay, this is Q. They will always give you the labeling. It's just for you to follow the instruction. OQ, this should be O. OQ, O prime Q, this O prime Q, and normal O, OI, O prime, N prime, produced, okay. I've already explained this. So this is the extension of this O prime, N prime to what? To Q. Then xi, measure and record theta. So we are expected to measure theta. We are expected to measure E. Where is E? This is E, the emergent ray. Okay, this angle, you will measure it with your protractor. Then we are expected to find D. D, look at from the diagram, D is from this normal to this normal, the distance, okay, is D. Then evaluate M. So for every evaluation in any practical, ensure that your reading is in 3 decimal places or in 3 significant figure. It is very important. If you don't do that, you'll be marked down. Okay, hello, you'll be marked down. So we have this on the board. So you can see this is M. They say we should evaluate M is equal to sine E. Look at it. Then we have N is equal to cos theta over 2. They say repeat the procedure for I is equal to 20, 30, 40, 50 degrees. So it means the experiment will be repeated for 10, 20, 30, 40, 50. Okay, so what does it mean? It means it's still the same thing. You are repeating what you have done before. Okay, I advise my students, don't do everything on a plain sheet. Okay, it's better you use plenty plain sheet than for you to come and write the WAEC again. Okay, don't you agree? So you do it on a plain sheet again, starting again on a plain sheet. What do you do first from the instruction? If you are able to understand the first procedure, the second procedure, the third, the fourth is usually not difficult. Okay, so you draw the outline, you put a normal quarter to DC, you draw I is equal to what, 20 degrees, and then you draw this line at this point. Okay, you fix P1, P2, you put the glass prism back with the mirror at the back. Then you align P3 and P4. Okay, you align it to P2, P1, and then you draw this line, put your normal, attach this point to this point, connect this point to this point, you draw this normal, and then you measure your theta, you measure your D, you measure your E, and that's it. Then you do the same thing for 40, 50, and yeah, the 50 is the last one. Okay, so without must, now we have this 10, 20, 30, 40, 50. You can see that for the theta, it is what, increasing. Okay, as the incident ray is increasing, the theta is what, increasing. The emergent ray is also what, increasing. Okay, and then we have D. D is also what, increasing. Then M is equal to sine E. What does that mean? It means the sine of 10 will give us this. Okay, if you punch your calculator, sine 10.0 will give us 0.174 approximately. Then sine 20.4 will give us this. Then N is equal to cos theta over 2. What does it mean? This is theta. Okay, so it means 10 over 4 divided by 2. Whatever you have, the cosine of it gives you this one. All right, okay, so now we are going to go to plotting of graph. Okay, I hope you understand the theoretical parts of this experiment, and I hope this theoretical part will help you in the experimental parts. Okay, so let's do the plotting of the graph. Okay, I don't know, we are to plot a graph of what, M on the vertical axis and N on the what, horizontal axis. Okay, so now usually I prefer we approximate M. Okay, approximate which other one? We are plotting M against N, so we are going to be approximating it to make our plotting easy. Okay, so we have M is equal to, this is what we are going to be using on the graph. M approximately, we have 0.2. Okay, let me use standard form. M will be equal to 1.0 1.8 times 10 raised to power what? Minus 1. Approximately 1.8, right? 1.8, this is, no, it's not up to 5. So we have 1.7, okay, times 10 raised to power minus 1. Then this will be what? 3.5 times 10 raised to power what? Minus 1. Then we have 5.0 times 10 raised to power what? Minus 1. Then the next one is what? 6.4 times 10 raised to power what? Times 10 raised to power what? Minus 1. Then we have 7 point, because this is more than 5, so it's going to be 7.7 times 10 raised to power what? Minus 1. Okay, of course, this is in degrees, right? Sign of E. Okay, so now to this, let's approximate this, okay, or convert to standard form. So if we convert this to standard form, we have this is n in degrees too. Okay, this will now be what? 9 points. It's looking similar, kind of similar, so I'm thinking of what to do, but we are going to plot it regardless. Okay, so we have 9 points. This is the same thing as 1.0, 1.0, we have 1.0 times 10 raised to power minus 1. Then this will be what? 1 point. Okay, it's going to be on 1 point. It's not going to make sense. It's not going to make sense. So this kind of graph, we are going to plot it this way. 0 points. Let's use 2 decimal places. If you approximate this, this becomes 0.10, right? If we approximate this, this becomes 0.99. Then if we approximate this, this becomes 0.992. This one becomes 0.97, 0.97, right? This becomes 0.972, 0.97. So we can plot this graph. You don't have to manipulate nothing. Okay, I know you'll be like, this graph is going to be kind of weird, but you don't have to manipulate nothing. You can plot it like this. Okay, so let's see how it goes plotting this graph. Let's plot this graph. Let's see how it's going to be plotting this graph. So please, I would like to do a transfer of this on this before we paste it. Let me do a transfer. So we have 1m 1.7 times 10 raised to power minus 1, 3.5 times 10 raised to power minus 1. Then we have n 0.1, 0.99, 5.0 times 10 raised to power minus 1 versus 0.99. Then we have 6.4 times 10 raised to power minus 1, 0.97, 7.7 times 10 raised to power minus 1, 0.97. Okay, so let's see how we can plot this graph. So we have this. First of all, the first thing you need to do is to draw your horizontal and vertical axis. That's the first thing you should do. I don't know if you are seeing what I'm doing. You draw your vertical and horizontal axis. Bear with me, drawing graph on the board is actually not easy. It's actually not easy drawing a graph on the board. So the next thing we label, I don't know if blue will be more visible. We'll label the graph. Remember, we're plotting M in degrees against N in degrees. The next thing you should do is put your 0, 0 here. Okay? So now let's plot. You find a suitable scale. This is what we have. 1.735567. Okay, let's see. 1, 2, 3, 4, 5, 6, and 7. Okay, it won't go because I have 7.7. So I have to reduce the scale. Let's do 2, 4, 6, 7, 8. Yeah. So let's do this. 2. But remember, it's times 10 raised to the power minus 1. So we have 2 times 10 raised to the power minus 1. 4 times 10 raised to the power minus 1. I hope you are seeing what I'm doing. Hello? Are you seeing what I'm doing now? So we have this to be... Is it clear? So we have 2 times 10 raised to the power minus 1. 4 times 10 raised to the power minus 1. 6 times 10 raised to the power minus 1. 8 times 10 raised to the power what? Minus 1. Okay? In degrees. And then this side, we can put 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. It won't go. Let's do 0.2, 0.2, 0.4, 0.6, 0.8. I think this will go. So 0.2, 0.4, 0.6, 0.8, 0, and then we'll have 1.0. So now let's see. Let's understand the scale. So it means this is 2. This here will be what? 1, 2, 3, 4, 5. Okay? Understood, right? Then this is 0.1, 0.2, 0.3, 0.4. Now, if we have the in between, will be like we have this is 0.1. It means this will be what? 0.12, 0.14, 0.16, 0.18, and then this is what? 0.2. Okay? I hope you understood. So we have this. Let's plot the graph. 1.7 times 10. So let's find 1.7. This is 1. This is 1.2, 1.4, 1.6. So 1.7 is in between here. In between. Okay? So let's chase it to 0.1. This is 0.1. This is 0.1. So we'll have it in the middle here. In the middle here. Okay? Now the next one we're plotting is 3.5. This is 3. So 3.5 will be in between, the middle. Okay, that's 3.5 before 4. So we have 3.5 will be somewhere here. We are going to share this box into 2. Okay, so we have 3.5, right? Is here. So now let's find 0.99. Sorry, this is 0.10. 0.99. This is 0.8, right? This will be 0.9. Okay, 0.99 will be in the middle here, somewhere in the middle here. Okay, before 1.0. So we have 3.5 in the middle here. Let's trace it. down to somewhere here. Okay, it is somewhere in the middle here. Okay, let me clean these dots. Hope you are following. Then the next thing we're plotting is 5.0. So 5 is here, this is 4, so 5 is here. This one is easy to trace. Then we have 0 is still on this same exact point, 0.99. Okay, we are manipulating nothing. Just plot whatever you have. Don't try to manipulate. Students tend to manipulate. They feel their graph is not going to be perfect. We don't check the graph whether it's not on its whether the points are scattered. That is, just plot correctly. You earn mark for plotting correctly. Don't manipulate. If what the calculator, this is what you got, use it in plotting your graph. Where was I? 5.0, 0.99. So we have 5 here, so 0.99 is going to be somewhere here. Okay, I don't know why my marker is trying to disappoint itself. It's going to be somewhere here. I hope you can see that. Is it glaring? Okay, so now we have the next one is 6.4. This is 6, right? We know this is 6.5, the middle. So 6.4 will be a point, a unit before 6.5. So we have 6.5 to be somewhere here, right? Before this thick line, this is going to be what, 6.4. This is 6.5. 6.4 will be somewhere here. So versus 0.97, we have 0.9 here. This is 0.9, right? This is 0.9. So 7, this is going to be 0.92. I see what I'm doing. 0.92, 0.94, 0.96. So 7 will be in the middle here. In the middle here. So we'll trace it up. We'll trace it up. Trace it up to 6.4. 6.4 is here. Then the next one is 7.7. We have 7.7. Where is 7.7? We have 7.7. We have, this is 7. 7.7 will be 7.7 will be somewhere up here. This is 8. So 7 will be in middle here versus 0.97. So it's going to be somewhere here too. Okay.